Hello guys, Mr. Lau here. So today I'll be going through tutorial 5 under the chapter from pressure measurements. Okay, so let's look at the first question. So what we have here today is a U-tube manometer filled with mercury, which is used to measure the pressure of water in a pipe. So this is the pipe. Okay, the mercury is 0.3 meters below point A in the left hand limb and 0.15 meters above point A on the right hand limb. Assuming the specific gravity of mercury is 13.6, the density of water is 1000, determine the gauge pressure of the water in the pipe at point A. Okay, so I will label the two critical points first. So over here I'll label this as point B and this at point C. Okay, so we know that from our theory that the pressure at B, okay, in this case gauge, will be equivalent to pressure at C gauge. Okay, so pressure at B is contributed by PA, which is the pressure in the pipe, plus the pressure due to this column of water. So plus pressure due to water. This is equals to pressure at C. So pressure at C in this case is due to the pressure due to this column of mercury. So pressure of mercury. Okay, so bear in mind everything here is under gauge pressure assumption. So PA is my unknown, so I'll leave it. For the water, it will be rho GH. Okay, same thing for the mercury, the formula is rho GH. So for the density of water will be 1000 times 9.81 times the height of this column of water is 0.3. Okay, and for the mercury wise, the density itself is 13.6 times 1000. Okay, so this is the specific gravity of mercury multiplied by the density of water. Okay, multiplied by 9.81 times the column of mercury here is 0.15 plus 0.3. So 0.15 plus 0.3 is 0.45. Okay, so we will calculate here on the left hand side and on the right hand side. So PA, when you work out, it should give you 57.09 kilopascal. Okay, so that's it for the first question. Okay, next, let's move on to the second question. For the second question, we have almost the same thing, also a U-tube manometer. Okay, the pipe is here, alright, and in this case, on the left hand limb, okay, we have the water column X1, the mercury column X2, and on the right hand side, this part is evacuated. That means it's basically just air, and this will be mercury. Alright, so again we label our critical points. In this case will be this point B and this point C. Alright, so using the same concept, okay, pressure at the same height of a continuous fluid will be the same. Okay, so PB will be equals to PC. So in this case, gauge, we are assuming gauge. Okay, so for PB itself, alright, this will be due to the pressure of the pipe, PA, okay, plus the pressure due to X1 column, which is this one, plus the pressure due to the X2 column, okay, which is from here to here. Alright, and for PC, since everything here is air, okay, so by right PC is atmospheric pressure, but since we are considering gauge pressure over here, okay, so the gauge pressure is 0. Okay, so PA is our unknown. PX1, okay, will be rho GH plus PX2 also rho GH. So for this X1 is due to water, so the density is 1000 times 9.81 times your height, which is 0.09, plus X2, okay, this is mercury, So again, we need to compute the density of mercury, which is 13.6 times 1000. Okay, the specific gravity times the density of water, multiply by 9.81, multiply by 0.05. Okay, so this whole thing here will be 0. So we can calculate this and we work out PA. This will give us a negative value 7.55 for kilopascal. Okay, so pretty simple, same concept of pressure measurement using manometer tubes. Okay, next, let's move on. Okay, we will move on to question number 3. Okay, question number 3, today same thing, we have another U-tube manometer. In this case, we have two pipes, pipe A and pipe B. So we are asked to calculate the pressure difference, okay, between point A and point B. Okay, we need the pressure difference between these two. Alright, so now we will label again the critical point. Okay, so here will be C, here will be D. So remember, we must always select the level, okay, which is matched up by the same fluid. So in this case, the mercury to the mercury, same level, therefore the PC gauge must be the same as the PD gauge. Okay, so what will this PC gauge be contributed by? PC will be due to PA, okay, plus due to this column of water and this column of water and also this column of water. Alright, so today we have 3 different columns of water, okay, which we can calculate the pressure. However, we do not know the height here. Okay, doesn't matter, we can just label it as X, because later you will see that it will cancel off, because the height of water here is the same as the height of water here. Okay, but for consistency, if you want, we can just put it as X. Okay, so this will be rho GH due to the full length of column of water here, okay, which is equals to PD. PD here is due to PB plus same thing, this column of water and this column of mercury. Okay, so PA is unknown. So over here, this full length of column of water will be 1000 times 9.81 times the H in this case is 0.6 plus X plus 0.2. So it's 0.8 plus X. Okay, which is equals to PB plus rho GH here is this column of water. So this is rho, which is 1000 times 9.81 times X. Okay, plus this column of mercury. So it's 13,600 times 9.81 times 0.2. Okay, can. So you see the left hand side and the right hand side, okay, both have this same term, so we can cancel it off. Alright, because they will subtract one another. Now 1000 times 9.81 times X will subtract with 1000 times 9.81 times X. Okay, so the remaining term I have is PA minus PB. Okay, I bring this term across. So let me write down the mercury term first. Minus 1000 times 9.81 times 0.8. Okay, so PA minus PB will be this whole thing, and if you compute, you should be able to get your 18.84 kilopascal. Okay, can. So that's it for question 3. So remember, for question 3, the thing here is that even though this column of water is unknown, it doesn't matter, because mathematically it should be able to cancel off. Alright, can. Okay, now for the last question for tutorial 5. Okay, we have this again a U-tube manometer, okay, with a tab on the left and another tab on the right. Okay, connected. Okay, first we need to find out the pressure difference between point B and point A. Okay, so we need to find out these two, the pressure difference. So again, same concept. Let me label this as C and this as Z. Okay, so we know that PC gauge must be equals to PD gauge. Okay, can. So for PC gauge, alright, it will be due to PA plus, okay, this column of water. So this column of water consists of this 50 cm plus again an unknown here. So again, unknown, as I mentioned just now in question 3, we don't need to be afraid. We can just label it as X. Okay, so this will be again rho GH first. PD will be due to PB plus this column of water and this column of mercury. Okay, so PA plus 1000 times 9.81 times the H in this case will be 0.5 plus X. Okay, 0.5 is the 50 cm. Remember, you must change it to SI unit. Okay, then X is the unknown. Is equals to PB plus this column of water, which is 1000 times 9.81 times X. Okay, X again because it's this column, plus 50 cm of mercury. So 13,600 times 9.81 times 0.5. Okay, can. So from here you can cancel your X. Okay, 1000 times 9.81 times X will cancel with 1000 times 9.81 times X. Okay, so you can work out your PB minus PA. So in this case you will get negative 61.80 kilopascal. Okay, can. Good. So this is for part A. How about part B? Part B, okay, they want to find the gauge pressure of water in tap B if the pressure at A is equivalent to 0.5 meter of mercury. So what does it mean to be equivalent to 0.5 meter of mercury? So it means to say that PA, okay, can be computed by rho GH, whereby the rho is 13,600 times 9.81 times 0.5 meter. Okay, that means the pressure at A is equivalent to that of the pressure created by a 0.5 meter column of mercury. Okay, can. So this will be your PA. So with this PA, okay, I can sub this PA into my PB minus PA equals to negative 61.80. Okay, so I'll take this value and sub here. So PB minus away 13,600 times 9.81 times 0.5, which is equals to negative 61.80. Okay, in this case this is kilo, so maybe I must times 10 to the power 3 to make it to the same units. Okay, so here also times 10 to the power 3. Okay, so from here I can work out my PB to be 4905 Pascal or 4.905 kilopascal. Okay, can. So that's it for tutorial 5. Okay, concepts are pretty simple. Just have to understand that how a manometer works and the idea of